All right, so today is 5-2. We're going to verify trig identities. So similar to what we've done before, but you only have one objective here. You're just going to verify. So that's exciting, right? We just have to do it. We just got to verify them. So what you're going to have to do is look for techniques for where you can show. What we're going to do is we're going to have two sides now, so we're going to have an equal sign. We're not going to move things to the other side because we haven't shown that the two sides are equal. So what we're actually doing is showing that the two sides are equal, that we can get one side to look like the other side. And so usually what people find is that this is a little bit easier because you know where you're supposed to get to. It's not like a simplify problem where you're not sure where you're supposed to stop. It actually has something on the other side, so you have somewhere to kind of go with it and have an idea of where you need to end up. In order to do that, you will need to use your identities on your formula sheet, rules from algebra, and then rewriting trig expressions. And then something else we're going to talk about is the idea of a conditional equation, is that an equation is true for only some values in its domain, where an identity would be true for all values in the domain. So what that means is, like, a conditional equation would be to say that the sine of x equals 0. Like, that's a true statement as long as you pick the right value for x that would make it equal to 0. Or if you said like x plus 2, if we said like x plus 2 equals 5, that statement's true as long as x is 3. Right? But if you plugged in some other number, it wouldn't be true anymore. So a conditional equation means like it's true for some numbers, but it's not true for all numbers. Where when you have your identities, it's true for every number. So it doesn't matter what you plug in for x, you'll still get the exact same thing on both sides. So if you plugged in a 2 for x or you plugged in a 7 for x, you're going to get equal values on both sides. So that's what makes it an identity. All right, what you're going to do is kind of the steps that you might take as you're trying to verify these identities is to work with one side at a time. So sometimes when we look at these, we'll notice that one side's a lot more complicated than the other side. And so you'll probably start with the side that's a little bit more complicated and try to simplify it down to look like the other side. You might look for opportunities to factor or to add fractions together, maybe to square a binomial to create like a difference of squares that you could then maybe substitute in for. Look for opportunities to use your identities. And some of that is look to see where you want to end up, and sometimes that can help you pick the identity that you're going to choose. Sines and cosines tend to pair up well. Secants and tangents pair up well, and cosecants and cotangents pair up well. And then when all of those ideas don't help, maybe try converting everything to sines and cosines. But the key is you need to always just try something. So sometimes you'll get going on these and you'll feel like, you're 18 steps into the problem and it's not going anywhere, which means you probably should just stop and start over and try something different. I wouldn't get 18 steps into the problem. If you're 4 to 5 steps in and you're not making any progress, you may want to try to just stop and see if there's a different approach you can take for it. So some of these problems you won't necessarily get on the first try and you'll have to try it again. So our notes for the most part today are just practicing that concept of verifying trig functions. So just verifying that the two sides are the same and going through a lot of different scenarios. So for this first one, we need to verify the identity. So I would first start and look for determine if one side's a little bit more complicated than the other. So here, obviously this side right here has a lot more going on than sine squared. So it's probably going to be easier to simplify the left side than to complicate the right side. And so then looking at the left side, I would maybe look for any trig identities that might help that we could substitute in for. So in the numerator where you have secant squared minus 1, if you look at your formula sheet, secant squared minus 1 is tangent squared. So we could plug in a tangent squared theta for our secant squared minus 1, and then that's going to be over a secant theta. And remember, with this equal sign, we're keeping these two sides separate. We're not crossing that equal sign. If you're someone who struggles with having your work in a nice, orderly fashion, so when you're doing these, I'm going to assume that whatever's under your left side probably goes with your left side, and whatever's under your right side goes with your right side. So if you need to draw the line in your paper, but if you're someone who starts on the left and kind of moves and does some figure eights with your work, and then you've got arrows everywhere, and you're going to probably get comments like, I couldn't follow your work. So you need to keep it nice and organized so that way who's ever grading it, which is me at this point, can figure out what you were thinking as you were going through it. All right, so if we need to get to sine squared, let's then, instead of dividing, let's change things into sines and cosines and multiply by the reciprocal. So tangent is sine squared over cosine squared, right? And our secant, isn't our secant squared 1 over cosine squared? And so instead of dividing by secant squared, which would be dividing by 1 over cosine squared, we could multiply by cosine squared over 1. So when you have that cosine squared, oh, this was supposed to be a cosine squared, sorry. When you have that cosine squared in your numerator and in your denominator, they simplify, and you're left with sine squared. Which, if you look over at the right-hand side, is that what we wanted to get to? Yep, so then you can give yourself some encouragement if you want. You can say, yep. All right, example 2. If, again, we're looking at this, and we notice that on the right side, we just have one term that we're multiplying a couple things together. But on the left side, we have two fractions. So again, I would think it's probably going to make more sense to combine the two fractions than to try to create two different fractions over on the other side. Okay, and we're going to keep the sides separate. And so if I want to add the 1 over secant minus y plus the 1 over secant plus y, I need a common denominator. So the denominator, right, will be secant y minus 1 times secant y plus 1. This first fraction right here needs a secant y plus 1. And then this one over here needs the secant y minus 1. And so hopefully you're starting to recognize that when you have that trig function minus 1, trig function plus 1, that's factored as a difference of squares. And so if we simplify the numerator, we get 2 secant y over, and if we multiply the denominator, we get secant squared y minus 1. Whenever you have a trig function squared plus 1 or minus 1, I would always look at your sheet to see if that's an identity. And we can see then that secant squared y minus 1 is tangent squared. And then keep in mind what we want to get to. Right, so we want to get to a cotangent and a cosecant. And so maybe it makes sense to change things into sines and cosines. Right? If we have 2 secant Isn't that the same thing as 2 over cosine? So here we would have 2 over cosine. And if we're dividing by tangent squared, so we're dividing by sine squared over cosine squared, that means we're multiplying by cosine squared over sine squared. Right, these simplify. And you're left with 2 cosine y over sine squared. And so then what might be helpful then is you're like, well, I'm not sure what else to do there. So go over to your right side and change that into sines and cosines. So change your right side now into 2 cosine y over sine y times 1 over sine y. So if you feel like you get stuck on one side, maybe it would help then just to move to the other side and see what you can do there. So if we do this, now we get 2 cosine y over sine squared. And is that the same thing we had on this side? Right? So yep, we're good. Excited about that. All right, so the next one we have a cosecant squared minus 1 times a cosine squared minus 1, and we need it to equal a negative cosine squared. So again, probably simplifying the left will make more sense than trying to get the right side to be looking like the left. I would maybe do trig identities if you have them. So cosecant squared minus 1 we know is cotangent squared. And cosine squared minus 1 is negative sine squared. So since the right side is cosine, it would probably make sense to change cotangent into cosine over sine. So we'll have we'll have cosine squared over sine squared times a negative sine squared. Right, and this is really like it's over 1. And so then this sine squared simplifies with that sine squared, and you're left with a negative cosine squared, which is what we wanted over on the other side. So we didn't even have to go over and change that right-hand side. All right, so for this one, did you change cosecant into 1 over sine? And you change tangent into sine over cosine. Your sines simplify, so you're left with 1 over cosine. And when you glance over to this side, you see that you need to get to secant. And so hopefully you recognize that 1 over cosine is the same thing as secant. So we got that. All right, so looking at the next one, we've got the beta in there, which is really just kind of like a Greek letter B. But when we have this, you've got a couple different things going on. We have that the cosecant of beta plus 1 needs to equal the cotangent of beta over the secant beta minus tangent beta. So both sides are not great, but because that right side isn't a fraction, you're probably not going to necessarily want to start with that and try to create a fraction out of it unless you were to go common denominators. So again, when you have, if you look at the right side, you have secant minus tangent in your denominator. if you were to be able to create a difference of squares and have secant squared minus tangent squared, if you look at your formula sheet, secant squared minus tangent squared is 1, right? So that would probably be worth trying to create that difference of squares over on that side. So what we're going to do is multiply by secant beta plus tangent beta in the numerator and the denominator. So that way when we multiply that fraction, we have that difference of squares in the denominator, not multiply the fraction, multiply the factors. So we'll have cotangent beta times secant beta plus tangent beta over, when we FOIL out the denominator, we get secant squared beta minus tangent squared beta. And then that denominator of secant squared minus tangent squared, that's 1. So you have cotangent beta times secant beta plus tangent beta. So you're a lot closer to having that right side. I would distribute cotangent through. So you'll have cotangent times secant plus cotangent times tangent. If you're not sure what cotangent times secant simplifies to, change it into sines and cosines. So cosine beta over sine beta times 1 over cosine beta plus, if cotangent and tangent are reciprocals, when you multiply those together, you're going to get 1. It's like if you multiplied 2 times 1/2, you'll get 1, or 3/4 times 4/3, you get 1 when you multiply reciprocals together. So this whole quantity right here will just be 1. Your cosines simplify, and so you're left with 1 over sine plus 1, and 1 over sine is cosecant. And cosecant beta plus 1, if you go back to the beginning, is what you had over on this side. So you got it. All right, so let's look at the last one here. And again, both sides are kind of complicated. So we may end up doing something to both sides. But when you look at it, hopefully you notice that you have that secant minus 1 in your denominator. And if that was a secant squared minus 1, if it was a difference of squares, we could substitute in a tangent squared, right? Which would help us with that tangent squared we have in the numerator. So it will probably make sense then to multiply this by our secant theta plus 1 over the secant theta plus 1 to create that difference of squares in the denominator. And so then we would have secant theta plus 1 times sine theta times tangent squared theta over, when you do your secant theta plus 1 and secant theta minus 1, that gives you secant squared theta minus 1. Which we're going to make that, so secant theta plus 1 times sine times tangent squared, so rewriting that numerator. We're going to make our secant squared theta minus 1 into a tangent squared theta. And so now you have those 3 terms you're multiplying in the numerator. 1 is tangent squared, so this tangent squared will simplify with that tangent squared. Okay. We could distribute our sine. So we would have secant theta times sine theta plus sine theta. Right? Secant theta is 1 over cosine. So if this is 1 over cosine, you have 1 over cosine of theta times the sine of theta plus the sine of theta. You would have sine over cosine, so we would have tangent plus sine. And at that point, you're probably like a little bit stuck on the left, right? And you're not quite there on the right. So it might make sense now that we're going to simplify on the right-hand side. So what I would do is take my cosine theta plus 1, and instead of dividing by cotangent, you're going to multiply by tangent, which is sine over cosine. And if you distribute, you get cosine theta sine theta over cosine theta plus sine theta over cosine theta, because we're distributing this whole quantity in. Your cosine theta simplify, and you're left with sine theta plus sine over cosine, which is tangent. And you get it. So sometimes when you go down the left side or the right side and you just kind of get to a point where there's nothing else you can do, it might make sense then to hop over to the other side and see if you can work that out to get to wherever you got stuck on the opposite side.